Now, if we cast our minds back to the Summer Olympics and the Australian pursuit cycling team, we remember that there was a stem failure related to one of those riders, and the rider went down, and it was pretty embarrassing for the Australian cycling team and also for Bastian Cycles, who actually had made that component. Well, anyway, after all of this time, the report has now been released. It relates to the investigation that was involved, and that is a 171-page report. But there was a few findings and recommendations related to that report, and there was a number of contributing factors that related to that stem failing and why it failed. So let's roll that intro and let's dive into it to actually see what the report found and what the recommendations were. What initiated the original problem, I believe anyway, was that it was identified that if they reduced the frame size of the bikes, then they could get more aerodynamic. And this was found sometime in relation to when they were training on the bikes. And the frames were then adjusted so they could make them more aerodynamic. So the Argon 18 frames they were using, then the riders were using a slightly smaller frame. So to get the actual fit for the riders, then they had to extend the stem, and it had to be extended 35 mil. Now 35 mil is actually quite a lot when you think about it, when our normal stems on our bikes are usually around about 100 or 110 mil. So that's like 30 to 40% of that distance longer if it was that length. So that was a contributing factor. And of course they needed to have this made, and they only had a year to basically work out what they wanted, how it was going to be made, and what specifications they needed to make that. So there was a reduced time frame than what they normally would have used. So it was like a bit of a rush. And this is what I believe contributed to all of the other factors that happened as we go through the report, and we can see a lot of other things that were really compounded the fact that it was being rushed. So they made some mistakes in the process of getting that to a finished product to get it onto the bike. Now, the key element that really sent them down the wrong path was that the specification didn't allow for the full loading on the handlebars. It was about 1.5 times less than what could be exerted on the handlebars. So basically the handlebar was under-designed. The stem and handlebar was under-designed, or the figure that was given to Bastian Cycles was less than what it should have been to withstand the loading of that cyclist on the bike. So that was the first factor that contributed. It was a time frame. Maybe they got that wrong loading because they rushed it and they go, oh yeah, it's this loading, quickly went through, or they used the loading of the shorter stem. Something happened at that point where they decided to use a certain loading which really wasn't adequate for the job. So they went to Bastian Cycles and said, this is how we want it made, this is what we want done, and we want you to do the fatigue testing to this loading forces. So Bastian Cycles go, oh yeah, okay, we can do that. And a lot of the information that was discussed wasn't documented properly as well. So then it's very hard to go back and say, hey, look, exactly what you want. We've got something written to show that the engineering's been done correctly and so forth. Well, the next issue that came about is that they normally have a fatigue cycle that they do at Bastian Cycles. So once you make a part, then you have to do what they call a type test. Now, a type test is where you take one particular item from that design. So you're not testing every one, you're just taking one piece. Just say you're making 100,000, you would take one that's of that design and type, and then you would do a type test on it. And that's what Bastian Cycles do. And if you've watched any of their videos on how they do their bikes, they've got a rig there and they can put them through fatigue loading. Well, what happened is it was supposed to be 200,000 cycles to do the full fatigue test for these handlebars, but for some reason it was decided to reduce this to only 50,000, so it didn't go through the full fatigue cycle, which may have picked up the fact that the design criteria was underrated and it might have actually failed. And then they would have scratched their head and probably gone back and redesigned it. But because they reduced the fatigue cycle, they didn't pick anything up. So production moved forward and they thought they were all on track to go to the Olympics. The next item that may not have contributed to the factor, but it was something that was not communicated between Bastian Cycles and Oz Cycles. Oz Cycles had a process for building the bike up and torques associated with putting the parts on the bike. And what happened is the Bastian Cycles torque figures were much higher than the torque figures that were related to Oz Cycles in their process, which was 6 to 8 newton meters, which is what we normally do on our carbon parts. But for this titanium part, it was supposed to be done up at 12 newton meters. So there was a gap there. And they're saying that because this was a lower torque, this could contribute to some extra movement or flexing between the parts where it was mounted on the bike. So that could have been another contributing factor that related to the fatigue of the handlebar and eventually breaking. So in conclusion, what I'll do is I'll leave a link to the full report down below. It's a bit of a read, but if you're interested in that sort of stuff, go in there. It talks about all of the specifications and all the parts they made. It's pretty comprehensive. But I just will quickly want to cover the findings in summary. And the first thing was the specifications were not correct. They were given, the actual loadings were 1.5 times greater. The cycles of testing, the fatigue testing, were reduced from 200,000 to 50,000 cycles. The consultation with Bastian was sparse, so they didn't really give them very detailed information. Australian cycle team policies and procedures were scant. Those in existence were not followed whilst verbal interaction was used without documented follow-up. So it's more like, oh, I just have a bit of this is what I'm after and blah, blah, blah. And it was kind of a bit of interpretation used there. The Australian team policies and procedures, read that one. Bastian Cycle was asked to design and make the base bars in a very short time frame. So it was a reduced time frame due to that. With the applied forces as specified, the contemporary design methods did not show any unusual stress concentrations ahead of the base bar front mounting bolt. Under some 1 and 1.5 times the specified forces, that area became especially sensitive to fatigue. The base bar showed a 0.29mm bulge on the front of the clamping base to the steerer fork. So when it got clamped up, there was shown to be some bulging of the metal there, and that was another point. That was not tested in the report. They asked Bastian Cycles to come back and basically do some investigation into that. The Australian cycling team had already had some experience with Bastian Cycles with some cranks and other materials, so they were kind of maybe a little bit lax because they had had like a good run with their parts before. In use, there was base bar inspections to detect in-surface degradation and corrosion, but they were missed. Because Bastian Cycles provided no advice on the base bar mounting bolts, it was not required to. It would have been prudent to do so as well. They were unaware of the Australian Cycles Team Bastian build book, which relevant torques values were stated, which I said they were quite different. The amount the Bastian biker would have recommended was higher than what Oz Cycles were using. Investigations of any technical failures must include an initial requirement to corral the failed item, associated suitable items or related documents. So I imagine that's for them afterwards to check out. During interview, muscle contractions in a static position called isometric exercise were found to use the racing bike frames as props. The estimate of force applied to the bike frame was ellipsed by the race start applied force. However, the isometric exercise forces must have been considered in any future fatigue study. So basically what they were saying is that when they're starting or using on the exercise bike, there was higher forces applied to those handlebars. So that's really it, guys. It doesn't really look like it was Bastian Cycles. What happened is Bastian Cycles was making the base bars to requirements that were not fit for purpose. So unfortunately, Oz Cycles probably have to take most of the rap here for those handlebars failing, because there was a shortened time frame and they didn't give them all of the information required to make the base bars fit for purpose. Okay, guys, if you've got any questions or comments, leave them down below. And remember to smash that like button and subscribe. And I will see you next vid. Cheers.